On a graph, a solution to a system is the point at which the lines intersect. For a linear system, I want you to take a minute and picture what do you think those graphs will look like if we have one solution, if there is no solution, or if we have an infinite number of solutions. Here's an example of what a graph could look like if there was one solution, if there is no solution, or an infinite number of solutions where we have one line on top of the other. If there is one solution, you'll notice that these two lines have different slopes. They also can have either different y-intercepts, as is the case in our first graph, or if the solution is the y-intercept, they could also have the same y-intercept. If we have no solution, the lines will never intersect, which means that they're parallel. Now, we know parallel lines have the same slope, and they're going to have different y-intercepts because they're crossing the y-axis at two different places. And if we have an infinite number of solutions, those lines are intersecting at every single point, which means they're right on top of each other. We call those two lines coincident lines. If it's the same line, they're going to have the same slope, and they're going to cross the y-axis at the same location. Each of these equations is linear. They're both degree 1. By finding the y-intercept and the slope on each of them, I can determine the number of solutions they're going to have. In order to get that information, I'm going to rearrange it into slope-intercept form for each, and then that will quickly identify what is the slope and what is the y-intercept. Once they're each rearranged into that y equals mx plus b form, I know that the slope on my first line is -3, my slope on my next line is 1/2. They have different slopes. They also have different y-intercepts, which means that I have one solution. There's two different lines and they're going to intersect at one place on the graph. In my second example, this second equation is into y equals mx plus b, so I'm going to rearrange the first one, and when I do that, I can see that they both have a slope of 1/2, and they both have a y-intercept of 3. That means I have two lines that are going to be on top of each other on the graph. They are coincident lines, which means I have an infinite number of solutions. At every point along those lines, they're going to be on top of each other intersecting. And in this example, we can see that this equation is already in slope-intercept form. I have a y-intercept of +0 because we don't see it. When I rearrange this one into slope-intercept form, I can see that I have the same slope on each line, and I have different y-intercepts. That means the lines are going to run parallel to each other. They will never cross. I have no solution. Let's take a look at how we can apply that information. We have 4 vehicles traveling down a long, straight stretch of highway, so kind of like the Trans-Canada Highway in the prairies. At this point in time, we know that the car is 40 kilometers from the starting point, the minivan is 25 kilometers away, and so on. This is my initial value, so on my graph, at this point in time, this is going to be my y-intercept. The rate is going to be the slope. So I know, for example, the car is going to travel a distance of 90 kilometers in 1 hour, a distance of 90 kilometers in 1 hour, and so on. I always want to draw a sketch just so I can visualize what's happening. And then knowing that this is my rate, my slope, and knowing that this is my starting value, my y-intercept, I can actually create an equation for each of those vehicles to represent what's happening. Now take a look at the question, and we're asked to both identify and interpret the solution, supposing that the vehicles continue to travel at their current speed. So in the first example, we're comparing the car to the minivan. So if we take a look at the graph, my car is in blue, my minivan is in green. So I can tell the car is further ahead than the minivan, but because they're both traveling at the same speed, the minivan is not going to catch up to the car. So they're going at the same speed, and the minivan is always going to be behind the car. I want you to pause the video and see if you can compare the next two, the car and the RV. I can see that they're both the same distance from our starting point at the point in time that this measurement was taken. They're also traveling at the same speed, so that means it's going to be represented by the same line on the graph. Most likely the RV is going to be pulling the car, so they're traveling at exactly the same point in time at the same speed. And then when I compare the truck and the RV, I can see that the truck originally is not as far as the RV. So here's my RV on the highway, here is my truck. However, the truck is traveling much faster than the RV is. So the truck is most likely going to eventually pass the RV. We also could have the car pulling the RV. You want to make sure that you can both visualize what's happening as well as interpret what the solutions mean given the context that you're presented with.